So welcome to our channel once again. In today's video on our JAMB Chemistry exam revision series, we have these 10 questions to answer on the topic chemical equilibria. So guys, this video will be all about Chatellier's principle and equilibrium constants. So in short, to stay till the end of this video, as this is very important as you prepare for your JAMB. Also, you know that where you feel you want to answer any question before we provide the answer, you can always pause this video and try out to see if you can get the answer to the question even before we provide the answer thereafter. So guys, we're starting with the first question here, and here we have an equation of a reaction. So we have N2, which is nitrogen gas, plus O2, which is oxygen gas, reacting to produce 2NO gas, and that's nitrogen monoxide gas. So guys, we have delta H to be positive 180.6 kilojoule per mole. So we have here in the reaction above, increase in temperature will A, decrease the yield of NO, B, increase the yield of NO, C, increase the quantity of N2, D, decrease the quantity of O2. So guys, the answer to this question is option B here, and that's increase the yield of NO. Since this is an endothermic reaction, an increase in the temperature will favor the forward reaction, and that means NO, which is nitrogen monoxide or nitrogen 2 oxide, will increase in yield. So that's it about this question. Let's consider the next question, guys. Question number 2. It says, consider the reaction represented by the equation 2SO2 gas plus O2 gas to yield 2SO3 gas, delta H being negative 197 kilojoule per mole. So which of the following conditions will not increase the yield of sulfur 6 oxide? A, increase in temperature. B, addition of O2 into the mixture. C, increase in pressure. D, decrease in temperature. So guys, the answer to this question will be increase in temperature. So since this is an exothermic reaction where delta H is negative, we have that an increase in temperature will not favor a forward reaction in this situation. So guys, that's it for this question, and that's option A. So let's consider the next question. Question number 3. It says, which of the following is true of Le Chatellier's principle for an exothermic reaction? A, increase in temperature will cause a decrease in the equilibrium constant. B, addition of a catalyst will cause an increase in the equilibrium constant. C, increase in temperature will cause an increase in the equilibrium constant. D, addition of a catalyst will cause a decrease in the equilibrium constant. So guys, the answer to this question is option A here. An increase in temperature will cause a decrease in the equilibrium constant. So according to Le Chatellier's principle, if a system at equilibrium is subjected to a change in temperature, pressure, or concentration of components, the system will shift its equilibrium position to counteract the effect of the disturbance. So for an exothermic reaction, an increase in the temperature will shift the equilibrium to the left, favoring the reactants and not the product. So this thus is decreasing the equilibrium constants. So guys, the next question we have here is question number 5, and it says, which of the following equilibria is shifted to the right as a result of an increase in pressure? A, phosphorus pentachloride in solid yielding phosphorus trichloride and chlorine gas. So we have option B, hydrogen gas plus iodine gas to yield hydrogen iodide. C, 2 molecules of ozone gas to yield 3 molecules of oxygen gas. And then D, 2 molecules of nitrogen dioxide to yield dinitrogen tetroxide. That's 1 molecule of dinitrogen tetroxide. So guys, the answer to this question will be option D here. This is because an increase in pressure will favor the side with the lowest number of moles. So guys, here you have two molecules of nitrogen dioxide, that's nitrogen 4 oxide, and then this is producing one molecule of the nitrogen tetroxide. So guys, that's it for this question. Let's consider the next question, and that's question number 6. It says the equilibrium constant Kc of a reaction is greater than 1. What does this indicate about the concentrations of the reactants and products at the equilibrium? A, the reaction does not reach equilibrium. B, the concentration of the reactants is greater than the concentration of the products. C, the concentration of products is greater than the concentration of reactants. D, the concentration of reactants is equal to the concentration of products. So guys, the answer to this question is option C here. The concentration of products is greater than the concentration of reactants. So if the equilibrium constant for a reaction is greater than 1, it indicates that at equilibrium, the concentration of the products will be greater than that of the reactants. So this means that the reaction will predominantly favor the formation of the products. That's it will favor the forward reaction. So let's consider the next question. Question number 7 here. It says Le Chatélier's principle states that if a stress is applied to a system at equilibrium, the system will A, shift to the left and favor the products, B, not change at all, C, shift to the right and favor the reactants, D, shift in the direction that reduces the stress. So guys, the answer to this question is option D here. That's to shift to the direction that reduces the stress. So let's consider the next question, and that's question number 8 here. It says equilibrium constant is also known as A, law of constant mass, B, law of mass, C, law of mass action, D, law of conservation of mass. So guys, the answer to this question is option C here, and that's the law of mass action. Equilibrium constant is also known as law of mass action. So guys, that's it for that question. Let's consider the next question. Question number 9. It says all these statements in the option given is false of Le Chatélier's principle for an endothermic reaction, except A, decrease in temperature will cause an increase in the value of the equilibrium constant. B, addition of positive catalysts will cause an increase in the value of the equilibrium constant. C, decrease in temperature will cause a decrease in the value of the equilibrium constant. And D, addition of a positive catalyst will cause decrease in the value of the equilibrium constant. So guys, the answer to this question is option C here, and that's decrease in temperature will cause a decrease in the value of the equilibrium constant. So guys, to understand this, a decrease in the value of the equilibrium constant translates that the reverse reaction will be favored. That's production of the reactants will be favored. So, and guys, that's the case when there is a reduction in temperature in an endothermic reaction. A decrease in temperature in an endothermic reaction will favor the reverse reaction. So guys, that's it for this question. Let's consider the next question. That's question number 10. It says that states that when a change in concentration, pressure, or temperature is applied to a system at equilibrium, the position of the equilibrium shifts in direction that tends to reduce the effect of that change. A, Dalton's principle. B, Boyle's principle. C, Le Chatelier's principle. D, conservation principle. So guys, the answer to this question is option C, and that's the Chatellier's principle. So this is where we end this video for today, guys. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not yet a subscriber. Also, if you have any specific question regarding this video, you can drop your question on the comment section below and we'll ensure to give you a response. We also want to encourage you guys to join our YouTube channel membership by clicking on the join button below, guys, in order for you to gain access to all the information we have for you on JAMB updates. This will help you a lot, guys, as you prepare for your JAMB examination. So thank you for watching this video and see you on the next one.